Assalamualaikum. So today our group will present the mini project for our assignment for this subject. And my name is Muhammad Elmi. So in our group we have 4 members. Okay, so the title of our project is Digital Clock using IC 4026. Okay, let's go. Here is member in our group. Okay, the first one is problem statement. Okay, the first problem, use various of clock in one place. Yeah, you can see this kind of problem happen during examination. Okay, so the second one, unclear time number. Yeah, this one you can see in exam hall. For example, the size of the display, the number of clock is very small. So if the person is far from the clock, cannot see lah. Okay, and go to the background of our project. So in this mini project, we use the common component that relate in our subject syllabus. So our lecturer told me to use the relate in chapter 2, 3 and 4, okay, to create this mini project. And use 555 timer will be used to generate clock pulse and IC 4026 to derive the 77 display. So this 7 display will display the time number. Okay, and we use 3 input AND gate. In multisim we can search IC 7411. So this input AND gate we use for increment and reset the value of clock. Okay,
Is Muhammad Danish bin Khairul Hisham. Okay, so today I will explain my part in this digital mini project, which is digital clock using IC 4026. Okay, so for my part, I will explain how the project works and how the project flows. Okay, so first, when we start the circuit, so the 7 segment display will display 000 count as soon this is okay. So for first, when we run the simulation, so this part is because I made this one capacitor values too low. So I will make it 1.5 micro. Okay, so I will start debugging. Okay, so for first start, so the switch for our digital clock is we are using 555 timer for the switch. So we don't use any switch. So we just use a 555 timer to give the input pulse or the input for our ICs. This is the IC 4026. Okay, so when we start the simulation, okay, so when we start the simulation, okay, we run the simulation. Okay, so the clock will start 1, 2, and 3, and so on. Okay, so this is slow because I made the capacitor 1.5 micro. So if I change the values lower, the faster the count will the clock will count. Okay. So as soon as the negative trigger from 555 timer, when the timer gives the negative trigger, which is high pulse obtained from pin 3 4026, and then from the 55 timer, it will give a high pulse to the first IC at the pin 3. Okay, so which is enable clock. So when the enable clock receives the input signal or high pulse, the high pulse fed to the first IC, which is this one, will end the increment its count to each clock, displaying 1 until 9 on the 7 segment. Okay, so this when the count from the 555 timer, okay, when zero count, the 7 segment will become 0. Okay, so that's clear, easy. When the count when 1, the server segment display will display 1. When 2, the server segment display will display 2. Okay, so that's what the outputs from the 4026 counter when they receive the input from the 555 timer, which is our switch. Okay, so and then after the 10th count was incremented by the IC 4026. I'm sorry. So the high to low signal was obtained from pin 5. The high to low signal is obtained from pin 5 at the IC 4026. 4026. That indicates the completion of 10 increment, which means when the 10 of this one, when the 10, it shows that it will show the increment of 10 increment is finished, is complete. So the next increment will jump to the next IC. So when this one is start 0, 9, and then 10. So the 10 will go, this one is 0. Okay, so this one is 1. And then it start over. Then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So after 10 counts was incremented by IC, sorry, next, this one. Sorry. So pin 5 of 555 timer connected to the next IC. So pin 5 from this one is our 555 timer. I'm sorry, the pin 5 from our IC 4026. Okay, this one clock out will go to the input, the clock pin for the next IC. I'm sorry. So whenever the 10 counts was completed by the server segment, whenever the 10, just now I said this one, whenever the count is 10, high to low at pin 5 from the IC will feed the single clock pulse input to the seconds IC. This is our seconds IC. So this is our minute IC, and this is our hours IC. Okay, so when the 10 increment or the 10 count increment is complete, they will shift it to the next IC. Okay, so the seconds IC will reset at number 6 because we need seconds only count up to 59 only. Okay, so what is mean by this part is our seconds IC will only display at 59 only. It will never go above than 59 because in a real world digital clock, it will display only 59, not 60, and then go to 1 minute. So it will show 59 and then it will go to 1 minute at the minute, for example, our minute IC lah. So let me show you. Okay, so when I start this one, okay, so this one I need to change the capacitor value. I need to fasting up. So let me 8.5 micro. Okay, so we run the simulation. Okay, so when the seconds IC is at 59, it will go to the next letter IC, will become 1. So this part will not have 60. So it is easy for us to read the digital clock as a normal clock. Okay, so let's wait for the ICs for the seconds will be 60 or 59. It will not become 60. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then look at that. It will not show 60. So it will go to 1 minute. not 60 seconds, 1 minute. Okay, so next is the seconds IC. Okay, this one. So same manner. For the fourth IC, will count from 0 to 6, and the value of fifth IC will be incremented by 1. Okay, so for this minutes, for the fourth one, which is this is the minutes IC, will only display until also until minutes also. We didn't show that 60 minutes. It also go to 1 hour. In real life, we don't call that. We didn't read clock as 60 minutes. We will say 1 hour. 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. Okay, so for hours IC, which is this part, fifth and sixth IC will reset after the number reach 23. So whenever it go to 23, because our digital clock is 24-hour system, so when it go to 23, and then it will become 0, 0, 0, 0, 0, 0 back, which is a 12 o'clock, if I'm not mistaken. Okay, so and then that's all from me. Thank you.
Okay, Assalamualaikum. My name is Idam Fahli bin Maiza. Okay, this is the circle which is digital clock circle that I and my friend construct. Okay, firstly we will use 5 timer on this circuit. We also use voltage source which is we set to the 9 volt. Okay, on the timer we use 2 resistor and 1 capacitor. Okay, for the if we increase the value for the resistor one, okay, the high time and the low time will be increased. Okay, for resistor 2 it will if I increase the value for R2, okay, the increase time will increase but the low time will be not changed. Okay, for the capacitor, on the capacitor, if I change the value for capacitor, okay, the frequency, the output frequency will be reduced. Okay, and then this is the IC that I use, which is 4026 IC. Okay, I use 4 IC because I use six, se- six 7 segment. Okay, each IC I will connect to the 7 segment. Okay, firstly I will show that the output for this IC, which is A B C D E F G. Okay, I will connect the output to the 7 segment to display the value. Okay, and then the clock. Okay, the function of the clock, it will increase the value from high to low, which is from low to high, which is 0, 1, 2, 3, 4, 7, 8, 9, 8, 9. Okay, and then I use 7 segment cathode on this circuit. Okay, 7 segment cathode. Okay, and then this is for second, and then this is for minute, and then this is for hours. Okay, I will run it. Okay, if you see the value will increase until 9, and then 5, 6, 7, 8, 9. Okay, and then after 9 it will transfer the output to this to second IC, and then it will transfer next. Okay, until 60. Okay, this is the PCB layout. Okay, we will see the PD. Okay, this is the circuit that if we do in a breadboard, okay, this is the circle. Okay, the yellow one is this one is looping, for looping. Okay, jumper wire.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Hafiz bin Ahmad Zaini. So I'm going to present the 3D digital clock circuit. And by the way, Happy New Year. So okay, from the schematic, we turn the diagram into the 3D view by produce it. So this is the front view. You can see the IC 7411, the AND gate, alright, and the 555 timer. Okay, so on the next page, okay, this is the back view. Okay, alright, this is the back view of the 3D diagram. Okay, this is the line at the back of the motherboard. Okay, the list of components. Okay, so the first one is the 555 timer. Okay, it is known basically a monostable multi-vibrator. The important characteristics of monostable multi-vibrator is as long as the pin 2 receive the positive trigger, okay, the output at pin 3 will be of low state. Alright, and when negative trigger was fed into the pin 2, the output at the pin 3 will go high for specific period of time. Okay, this time was decided by the resistor and capacitor connected with it. Okay, alright. Okay, this is the picture, I guess. Okay, can't see. Okay, this is another one. Okay, so the second component is the IC 4026, okay, also known as 60-pin CMOS 7-segment counter from the 4000 series. It counts clock pulses and returns the output in a form which can be displayed on a 7-segment display. Usually it is for the decimal display. Yeah, if you get the output in a decimal points, you will use this IC 4026. Okay, this is the picture. I'm sorry again, you can't see very enough. Okay, and then we moving on to the next one. Okay, this one is the IC 7411. It is AND gate. Okay, AND gate having 3 inputs and 1 output. This IC contains 3 AND gates. This is special. Okay, that's the picture. So there are about 5 input, I think. Okay, 5 input and maybe, or no, 7 input or 8 inputs, and the rest is output with the 226 VHC plus 5 VLC. Alright, this is the schematic. Okay, so for the last but not least, the conclusion. So the conclusion, we are able to apply in practical on what we have learned during the class to further deepen understanding on the subject and expose us to the use of many kind of sources in gaining a knowledge and information. During we completing the project, we developed skill of critical thinking and problem solving, as well as communication skill and teamwork spirit while doing the project by split the task among group members. I guess that's all from us, and thank you, madam.